Okay. On the stoichiometry with real chemicals, except we're going to make water at least. So we have H2 plus O2 forms H2O. What's wrong with that equation, guys? Come on. Somebody tell me. Nobody's telling me. It's not balanced. Put a 2 here, put a 2 here. Then the equation's balanced. We're going to look at 4 different types of calculations right now. One is called the mole-to-mole calculation. The mole-to-mole calculation is the one in your book that we went through with the turkey sandwiches, and it's the easiest one in your book. The next one is a mole-to-mass problem, where we have moles and we're going to grams. The next is the opposite of that. It's mass to moles. And lastly, we have a mass-to-mass problem, which is the longest and most complicated. One thing you're going to need to remember is that molar mass is going to let us convert from grams to moles. Okay, you know that already, but molar mass can get us from moles to grams and grams to moles using that figure 8 shaped table I gave you in the beginning. So this can be interpreted as 2 molecules of hydrogen react with 1 molecule of oxygen to give you 2 molecules of water, except for the fact we cannot weigh that. So we would want to talk in terms of moles. 2 moles of hydrogen plus 1 mole of oxygen will give you 2 moles of water. If we look at the masses here, the mass of H2 is 2. 2 times 2 is 4 grams. Each oxygen is 16 grams, so O2 is 32 grams. Water, 2 H's and an O are 18 grams, times 2 is 36. And 4 plus 32 is 36, and that's 36, and we have the law of conservation of mass being upheld. So let's start with 3 moles of hydrogen. And I want to find out how many moles of water I can make. So I'm going to start with my given, 3 moles of hydrogen. I'm going to go back to the balanced equation. I'm looking for water, and I see that 2 waters are produced for every 2 moles of hydrogen. The moles of hydrogen will cancel. 3 times 2 is 6. 6 divided by 2 is 3. And that will give me 3 moles of water. If I had 4.5 moles of water, and I wanted to know how much oxygen I needed, I can do the same thing. It's still, that should have been moles of oxygen. I can do the same thing. I'm going backwards. I'm going from the product to the reactant, but it doesn't matter. I write down 4.5 moles of water. I am looking at the balanced equation. It says I am going to need 1 mole of oxygen for every 2 moles of water I produce. 4.5, the moles of water will cancel. 4.5 times 1 is 4.5. 4.5 divided by 2 is 2.25 moles of oxygen. So those are mole-to-mole problems. And you can go from reactant to product. Let's try one that is mole to mass. Here I have 0.5 moles of oxygen, and I want to know how many grams of water I can make. To do that, I'm going to convert the moles of oxygen to moles of water, and then I'm going to use the molar mass of water to convert it to grams of water. So I take my given, 0.5 moles of O2. I look at the balanced equation up here. I want to find out how much water I can make. 2 moles of water are made from every 1 mole of oxygen. Okay, so now I'm at moles of water, and what I have to do is get to grams of water. If I want to go from moles to grams, I am going to multiply by the molar mass of water. Moles of oxygen have canceled. I have moles of water. I need grams of water on the top. I need moles of water on the bottom. The molar mass of water is 18 grams per mole. So 0.5 times 2 is 1, divided by 1 is 1, times 18 is 18 grams of water produced.